Hello guys, in this video I will discuss inference to the best explanation, or IBE, as an argument for scientific realism. IBE is a rule for choosing between rival theories. Let's say that there are multiple theories that can all successfully account for the observable data. This means that they are all empirically adequate. In this case, IBE tells us to choose the one that provides the most satisfying explanation. Consider this scenario. You walk into your university classroom 5 minutes before your lecture is supposed to start, and the room is completely empty. No professor, no students, nothing. Now consider these hypotheses to explain this. First is, university went bankrupt and the school permanently shut down overnight. The second hypothesis is aliens abducted everyone. The third is the professor and all 30 students secretly agreed to hide in the hallway just to prank you when you walked in. And the fourth is the lecture was moved to a different room and you missed the email. All four hypotheses are consistent with the observation that the classroom was completely empty. So we can explain why the classroom was empty by using any of these hypotheses. Yet, almost everyone would choose hypothesis 4. Why? Because it is simpler, more natural, more coherent with our background beliefs. They would think that is the best explanation. Inference to the best explanation is not a deductively valid form of argument. Consider this argument. If it rains, the ground is wet. The ground is wet, therefore it rained. Why is this invalid? Because it is possible for conclusion to be false when the premises are both true. It doesn't have to be a rain that's causing the ground to be wet. Maybe someone was washing their car or something like that. So this is a fallacy called affirming the consequent. But in terms of IBE, this is not a bad inference at all. If you walk outside, see gray clouds, smell that distinct rainy scent in the air, and see a wet street, you infer that it rained because it is the best, most coherent explanation available to you. Even though it is not deductively valid, it is the best explanation. Of course, we don't just use this in daily life. Same logic applies to how we do science. Scientists rely on this reasoning to understand things. Nobody has observed dinosaurs directly. Their existence is inferred because fossils are best explained by the hypothesis that dinosaurs existed. Or think about the continental drift theory. We infer continental drift theory because it is the most satisfying explanation for why the coastlines of South America and Africa fit together like puzzle pieces. You can think of other examples like the light from a star shifting toward the red end of the spectrum. This is called a redshift. And the explanation is the star is moving away from us. Notice that the redshift doesn't logically imply that the star is moving away from us. Other hypotheses are possible, but scientists infer this one because it provides the best explanation. IBE tells us to choose the best explanation. But what makes an explanation best? We can talk about several criteria. First is expectation. The hypothesis turns strange or surprising data into something expected. If your hypothesis is there's mouse in the wall, then the scratching sound is not surprising. Your hypothesis makes the data expected. Second is testing. We must be able to derive empirical consequences, and these must be testable and verified. A good scientific explanation should produce consequences that we can check through observation and experiment. Third is simplicity. Simpler and more natural theories are preferred over complex ones. The explanation should not postulate unnecessary entities. When two hypotheses explain the same evidence, we usually prefer the one that makes fewer unnecessary assumptions. So, when you hear a scratching inside the wall, and there are two theories. First one is there's a mouse in the wall, and the second one is there's a mouse in the wall, and also a hidden ghost is controlling the mouse to produce exactly those sounds. As you can see here, the first one is simpler. Fourth is coherence. Theories that fit well with our fundamental views on the nature of reality are favored. An explanation is judged by how well it integrates into our broader web of knowledge. The explanation must be compatible with our other scientific theories as well as our ontological or metaphysical views. Again, if you say that there's a mouse in the wall and also a hidden ghost that is controlling the mouse, this explanation is not compatible with our scientific and metaphysical commitments. The fifth one is scope. A theory with a unifying power is highly valued. We say that a theory has wide scope when it can cover a large range of phenomena under one explanation. One that explains many different types of phenomena at once. Of course, these criteria are only guides. They are not a strict formula. They do not guarantee that the chosen explanation is true or uniquely the best. One way to understand what best means is to think of the best explanation as the most likely explanation. So one can say that the best explanation is simply the most likely explanation. But this really doesn't enlighten us on what best means, because even if we assume that scientists infer the most likely explanation as the best explanation, we have to explain why scientists regard that one theory as more likely than others. Saying scientists infer the most likely explanation is like saying scientists infer what they think is probably true. I mean, of course, they will choose what they think is the most likely explanation. There's no doubt about that, but this just seems uninformative. Peter Lipton says that it is better to mean something like most explanatory or most insightful, or the explanation that offers the most understanding. He famously uses the word loveliest. So the best explanation is the loveliest one. He's not saying that scientists infer the most likely explanation. Instead, he's saying that scientists infer the most explanatory theory or explanation, which is the most likely one. This is a much stronger claim. So for Lipton, a lovely explanation is not just one that is probably true, it is one that would provide the most understanding if it were true. Scientists do infer what they think is the most likely hypothesis. They do that by looking at which hypothesis gives the best understanding. So a better explanation is better because it would help us understand the phenomenon more deeply. At this point, you might ask, okay, but how do we know when an explanation offers more understanding than others? How do we know that is the loveliest? Well, I mean, the 5 criteria I just mentioned are useful for comparing explanations, but we can also talk about other criteria. Causal view of explanation says to explain a phenomenon is often to cite the relevant parts of its causal history. For example, to explain why a window broke, we cite the relevant cause, which is a stone hit the window. So once we know the causes of causes that produce an effect, we understand it. We can talk about a mechanism criterion and say that an explanation is better if it describes the mechanism by which the cause produces the effect. A mechanism is the process connecting cause and effect. So it doesn't merely say that the stone caused window to break. It explains how the stone led to the breaking by saying something like the rock carries kinetic energy. When it hits the window, it transfers that energy to the glass, creating an intense mechanical stress or whatever. So an explanation is lovelier the more fully and richly describes the mechanism of the cause. And then there is the precision criterion. An explanation is better if it explains the phenomenon in more exact detail. Again, take the broken window as the explanandum. A simple explanation says a stone hit the window. A more precise explanation says a stone of this size thrown from this angle and at this speed hit the lower left corner of the window at this exact time, producing these exact cracks. The second one is better because it gives us a more detailed understanding of why the window broke in exactly the way it did. So when the explanation entails more precise features of the explanandum, it is better. The phrase best explanation may sound like there can be only one explanation, but this is not true. IBE doesn't restrict inference to a single explanation per a body of evidence. What matters is whether the explanations are competing or compatible. What do I mean? Consider this example. Our observation is that there are many birds in a certain area. This observation may support more than one explanation, right? One explanation is that there are no predators nearby. Another explanation is that food is abundant in that area. These explanations are perfectly compatible. Both may be true and both may be inferred. Birds may gather there because food attracts them, while the absence of predators allows them to remain there safely. So IBA isn't chasing exactly one explanation. Instead, it is a method for choosing among competing explanations. So best explanation really means best among competing explanations, leaving room for multiple compatible inferences. And there can always be compatible explanations because real-world phenomena are often not the result of a single isolated cause. They usually result from several causal factors that are working together. Now let's slowly shift to realism debate. First of all, there's something important that I like to mention, which is the difference between prediction and explanation. Imagine you have a friend who can perfectly predict the weather every day, but when you ask how, he just shrugs and says, I just know. I mean, in this case, I would say your friend can predict very well, yes, but he doesn't understand what's happening. So to understand why it happens, we need an explanation. And we are lucky because our best scientific theories do both, right? They give us incredibly accurate predictions about the world, but they also give us a deep explanation of the unobservable forces that are at play. And How does science actually explain things? It explains things by pointing to an underlying reality that we cannot see directly. But some anti-realists argue that scientific theory is just a tool used to make predictions. If the tool works, the story or the explanation we tell about why it works doesn't really matter. And the best argument to defend this view is underdetermination. There will always be multiple competing theories that can explain observations equally well. The correct theory is underdetermined by evidence. The realist's reply is yes, but fitting the observations is not the whole story. Two theories may be empirically equivalent, yet one may have stronger explanatory power. When several theories fit the evidence, scientists often choose not the theory that merely fits the data, but the theory that best explains data. So, when two theories predict the same phenomena, the realist argues that they aren't evidentially equivalent. Empirical equivalence does not imply evidential equivalence. Explanation matters in addition to prediction. We do not accept atomic theory, for example, merely because it saves the phenomena. We accept it because we think there are atoms. So we might have two theories, theory A and theory B, that predict the same data. But if theory A explains the data better, then we choose theory A. Think of chemical phenomena. We know that chemical phenomena occur, and atomic theory explains chemical phenomena very well, so scientists accept it. As another example, think of Cartesian skepticism. We all have sensory experiences like seeing trees, hearing voices, feeling the wind. Our ordinary common sense explanation says there really are external objects that are causing these experiences. But the skeptic says your experiences could also be explained differently. Maybe an evil demon is producing your experiences, or maybe you are a brain in a vat connected to a computer. So the evidence, which is your sensory experience, doesn't necessarily force us to believe the common sense view. Both the common sense explanation and the skeptic explanation explains the evidence equally well. In this case, why should we prefer the common sense view over the skeptical alternatives? The realist answer is because the common sense view is explanatorily better. Criteria such as simplicity and coherence is important here. And in this example, the skeptical explanation seems to introduce an ad hoc hypothesis that violates simplicity. The common sense hypothesis says the orange rolls because it is round. This is simple and direct. The spatial property itself explains the behavior. But the brain in a vat hypothesis says something like a computer simulates an orange, and this state behaves as if it were round because the computer follows spatial rules that make pseudo-round things, maybe, that behave like real round things. The realist might say that the skeptical explanation is inferior because it has to introduce a lot of artificial properties and extra rules. Okay, now I'm going to discuss a specific application of IBE, which is the use of IBE to defend scientific realism. We can divide the realist argument into two categories, one local and one global. They both use IBE but are slightly different. Local one goes like this. Scientific practice routinely use IBE. If we accept the rationality of scientific practice, then we have to accept that IBE is rational. Many successful scientific explanations involve unobservable entities. If IB is rational, then belief in these entities is also rational. This is the local defense of scientific realism. Also, there is the global defense of scientific realism, because just saying scientists use IB doesn't lead us to full-blown realism, because even if scientists use IB, we still don't know whether IB leads us to truth. Does IB actually lead to truth? This is a different question. A constructive empiricist, for example, may say that yes, scientists infer the best explanation, but they are not entitled to infer that the theory is true. We can just say that the best explanation is empirically adequate. The global argument, on the other hand, is something like this. The predictive success of scientific theories, is itself a phenomenon to be explained. And the truth of these theories is offered as the best explanation of that success. So a scientist sees fossils and goes to dinosaurs, whereas the philosopher sees successful predictions and from there goes to the truth of theories. Although the explanandum is different, the form is the same. This argument is called no miracles argument, and it is the most famous argument in favor of scientific realism. Why is science so successful? The explanation that the realist gives is science succeeds because its theories are approximately true, and the unobservable entities that are postulated in these theories really exist. If theories correctly describe reality, then their success is not surprising anymore. It is not a miracle anymore. And realists often claim not only this is far more better than any rival explanation, it is the only adequate explanation. Because think about it. We have microwave ovens and radios and things like that. Scientific theories say that they should work because electromagnetic waves exist. If someone denies the existence of these entities, then the realist asks, why do all these devices behave exactly as if the theories were true? So the most reasonable thing to do is to believe that theories about electromagnetism are approximately true. A key feature of this global realist defense is naturalism. According to naturalism, there is no distinct line between philosophy and natural science. The idea is, when philosophers think about science, they should use the same reasoning patterns that scientists use. If scientists are justified in using IB to infer electrons, then philosophers should also be justified in using IB to infer realism. If scientists use IB, philosophers should use IB too. If we use the exact same rules of logic in philosophy that we use in science, we are practically forced to admit that our best scientific theories are literally true. To deny it would be irrational by science's own standards. So realists look at the history of science the same way as scientists look at laboratory data. They observe that science works. They propose scientific realism to explain that success. Okay. Now I will move on to the objections raised against this argument. Let's see objection number 1. So our main question was, why is the scientific theory T successful? The realist says It is successful because T is true, right? But maybe truth is not the best explanation. If you ask an empiricist like Van Frossen the same question, he will say that it is successful because it is empirically adequate. We know that theory T is valuable because it has worked in the past, and that's enough. No realism is needed. The anti-realist can explain scientific practice in terms of its observed success. It doesn't need to explain that success by appealing to truth. One realist answer is as follows. IB doesn't require a unique explanation. Compatible explanations can both be accepted. So we can say that truth and empirical adequacy are compatible. When you say that a theory is true, it also means that it is empirically adequate. A theory can be both true and empirically adequate at the same time. The realist can accept both of them with no problem. Well, of course, this is what the realist thinks. What the empiricist might say in return is, oh no, I think the theory is empirically adequate. I don't think that it is true. If he says the theory is empirically adequate and false, now we have empirically adequate and false explanation, which is incompatible with the truth explanation. But does this really add something? I ask, why is the theory successful? You answer, because it is empirically adequate and false. So how does the falsity help us explain the predictive success here? It doesn't. So falsity adds nothing. It's like when I ask you, why does the car move? And you answer, because the engine is running and Napoleon lost at Waterloo. The second part of the explanation contributes to nothing. The second realist answer to the empiricist objection says that empiricist explanation is weak anyway. Empirical adequacy may not be much of an explanation at all, because saying theory is successful because it is empirically adequate is very close to saying that the theory is successful because it is successful. Why? Because empirical adequacy itself means predictive success, right? For example, imagine you ask, why does opium make people sleepy? And they say, it's because it has a dormative power. But dormative power simply means the power to cause sleep. So saying opium has a dormative power is merely a redescription of the fact that it causes sleep. Similarly, saying the predictions are successful because the theory is empirically adequate sounds like the predictions are correct because the predictions are correct. Empirical adequacy is defined as a property of making true observational predictions. So saying a theory is successful because it's empirically adequate seems circular. Objection number 2. The realist says the success of science would be a huge coincidence if our theories were not at least approximately true, right? And that we need realism to explain that success. However, this argument has the assumption that we must either accept scientific realism or accept that the success of science is an inexplicable, miraculous coincidence. Van Frossen says this assumption is false. He illustrates this point with a simple everyday scenario. Suppose you went to the shop and unexpectedly met a friend there. You call it a coincidence, right? You just bumped into your friend by a coincidence. And yet there are explanations. You can explain why you went to the shop, and your friend can explain why you went to the shop. He was there for a reason. You were there for a reason, and your paths happened to cross. This is called coincidence because you didn't plan to meet, but this coincidence is not completely unexplained. It just doesn't have a single unified explanation. We can explain a coincidence by explaining each part separately. We can give a localized causal explanation for each friend's presence in the shop. Coincidences can still have explanations. But the realist seems to assume, however, that if something is coincidence, it has no explanation. Von Frassen denies this. Many coincidences are perfectly explainable. Science, he argues, is not required to eliminate coincidences. But the realist might not be satisfied with this explanation. He might say that this explanation is not enough because think about it. Think about this. If you randomly meet your friend in the shop once, the local explanations are adequate. Yes, I came here to buy bread. He came here to buy cheese, and we met. But imagine you keep meeting your friend in the same shop every single day. In this case, wouldn't you look for a different, deeper explanation? Similarly, when you have repeated a predictive success over and over again, you would not like to take this as a string of lucky coincidences that are arbitrary. Instead, the realist wants a better underlying explanation, which is truth. Von Frassen gives his own anti-realist explanation for the success of science. He says, scientific success is not miraculous. Actually, this is exactly what we should expect. Why? Because unsuccessful theories disappear. So he compares science to biological evolution. In evolution, many organisms appear, most of them fail, and successful ones survive. Similarly, in science, many theories are proposed, most of them fail, and successful ones survive. So naturally, the theories that we currently possess are successful. Those are the survivors. According to this explanation, scientific theories are successful because scientists select theories for their success. The process works roughly like this. Scientists propose many theories. Some theories make unsuccessful predictions. Those theories are rejected, and the successful theories are retained. Therefore, it is not surprising that the theories currently accepted by scientists are successful. They survived precisely because they were successful. And this resembles biological evolution, in which many organisms exist. Poorly adapted organisms are less likely to survive, better adapted organisms remain, etc. Similarly, many theories are proposed. Unsuccessful theories disappear, successful theories remain. So how are we explaining the success of science here? We are saying that scientific theories are successful because scientists selected them. Let's go over with an example. Suppose you enter a conference room and discover that everyone has blue eyes. You ask, why does everyone in this room have blue eyes? Then you are told, this is a meeting only for the blue-eyed people. Only blue-eyed people are allowed to join in. This genuinely explains why everyone in the room has blue eyes, right? The group was selected according to that characteristic. Similarly, scientific selection explains why the theories we accept are successful. Lipton objects to this explanation. He says that the evolution explanation is only a phenotypic explanation. A phenotypic explanation explains why successful theories survive, but it doesn't explain why a particular theory was successful. Yes, scientists choose theories based on success, but does this really explain why theories are successful? are we really going to say that theories are successful because they are selected by scientists? I think of the blue-eyed club again. The club's rules explain why every club member has blue eyes, because the ones that don't have blue eyes can't get in. But it doesn't really explain why Alice or Tommy has blue eyes. Obviously, she couldn't have acquired blue eyes because she joined the club. That was something that happened before the club, and it needs a biological explanation. Well, we can say the same thing about science. We can say that scientific theory was selected because it was successful, but we cannot say that it was successful because it was selected. Just like Alice had blue eyes way before she ever knocked on the club door, a theory must possess whatever property makes it predictively successful before scientists test it and choose it. Let me give you another example. Why does a giraffe have a long neck? One answer is giraffes that have long necks survived better, and the short-necked ones died out. This is a selection explanation, a phenotypic explanation. But there's another question. Why does this particular giraffe have a long neck? The answer is, of course, because of its genes and biological constitution. This is a deeper explanation, which is a genotypic explanation. Similarly, why does a particular successful theory have successful predictions? The Darwinian explanation merely says that the theory survived. It doesn't explain why it generated successful predictions. And so Lipton says, Van Fraassen explains why successful theories survive, but the question is, why are those theories successful in the first place? And the realist's answer is, of course, because they are approximately true. The realist can also argue that Van Fraassen's phenotypic explanation and the genotypic explanation can be accepted at the same time. The selection explanation doesn't directly contradict the truth explanation. The realist can accept that successful theories are selected because of their success. He can then add their predictive success is evidence that they are true. So the realist can accept both. Theories survive because scientists select successful theories, and those theories succeed because they are true. The selection explanation, therefore, doesn't logically exclude the truth explanation. Anti-realists, in return, can say that, but just because they are compatible, it doesn't mean that I can't choose one. Even though these two explanations are compatible, one explanation may remove our reason for accepting the other. Compare Darwin's explanation of species to theological explanation that posits God. The God explanation says that organisms are remarkably well adapted to their environments. Such adaptation would be unlikely without a designer. Therefore, God designed organisms. Now, this doesn't necessarily contradict with the Darwinian explanation. One can say that, okay, I accept the Darwinian explanation, but I also think that God did all that, or something like this. So one can accept God and natural selection at the same time. But the problem here is that once you accept natural selection, it removes much of the motivation from inferring God from biological adaptation, right? Once natural selection explains adaptation, we really no longer need the designer or God hypothesis for that purpose. Similarly, if I accept Van Fraassen's selection explanation of scientific success, it means that I no longer leave the success of science as a miracle. So if I accept the selection explanation, it removes the need to infer truth from success, because the selection explanation removes much of the motivation for accepting the realist truth explanation. Of course, this doesn't refute the realist. The realist can still say that, look, selection explains why successful theories are accepted, but it doesn't explain why theories were successful in the first place. So our main problem still exists. Where are we now? Okay, another anti-realist objection comes from underdetermination. Let's go step by step. Firstly, the realist says that the truth of theory T1 explains why T1's predictions are correct. But there may be many theories that are incompatible but entail exactly the same predictions. They make the same observable claims but give completely different theoretical pictures. Suppose we have a theory and the realist claims that the best explanation of its predictive success is its truth. If you ask the realist, why did your theory successfully predict something? His explanation is something like this. The theory T1 is true. If a theory is true, all of its logical deductions, which are predictions, must also be true. Therefore, the prediction happened. This is the explanatory power of truth. Truth leads to correct predictions. But exactly the same rule applies to every rival theory, T1, T2, and T3. If T1 is true, its prediction P is true. If T2 is true, the same prediction P is true. If T3 is true, the same prediction P is true. The truth of each rival theory would explain the shared predictive success equally well. The truth of T1 and the truth of T2 are equally good explanations. The realist now has no uniquely best explanation. IBE cannot tell the realist to infer the truth of T1 because incompatible alternatives are just as explanatory. And it's very hard to beat underdetermination because the truth of all of these theories explain success exactly well. If you assume T1 is true, it perfectly deduces the successful predictions. If you assume the incompatible theory T2 is true, it also perfectly deduces those exact same predictions. And at this point, criteria like simplicity or coherence doesn't help us because truth explanation asks which theory's truth best explains why the successful predictions are true. It's not asking which theory gives the best scientific explanation of a phenomenon. If we accept both of them to be true, it guarantees the same successful predictions. Their truth does the exact same job of guaranteeing true predictions. So at the level of the truth explanation, neither theory explains the predictive success better than the other. Therefore, the truth inference doesn't properly qualify as an inference to the best explanation because there is no single best truth explanation. But it's important to note that the anti-realist is not some kind of radical skeptic. He knows that if you hear a scratching in the wall, it is perfectly reasonable to infer that there's a mouse. Von Frausen, for example, acknowledges that IB is indispensable. It is necessary for acquiring reasonable expectations about the world. He has no problem with using IB to conclude that a theory is empirically adequate. So von Frausen accepts many ordinary inferences that go beyond what has actually been observed, like the mouse. It's okay to infer the existence of a mouse that you haven't seen yet. But he refuses to infer the existence of unobservable entities such as electrons. And the reason I'm talking about this is this. The realist says underdetermination doesn't just apply to unobservables like electrons, it applies to everyday induction as well. Imagine a theory T which says gravity works the same way forever. And then imagine a rival theory which says gravity works normally until October 2026. And then it completely reverses. Up until this very moment, both theories are empirically equivalent, right? They have the exact same past observational evidence. Yet Van Fraassen normally prefers the first one and expects it to remain successful. And at this point, the realist argues that if you want to believe that gravity will keep working tomorrow, you must use IBE or induction to pick the first one over the second. If Van Fraassen refuses to use it, then he cannot rationally move from the sun has risen every day so far to the sun will rise tomorrow. He would have to suspend judgment about all unobserved cases, and this leads toward radical skepticism. Here, the anti-realist might say, the first one is simpler and fits our background knowledge better than the second one, so believing it is reasonable. But if he says that, it means that he is using IBE, right? The realist then asks, why does IBE support beliefs about unobserved events like the mouse or the sun that will rise tomorrow, but not beliefs about unobservable entities like electrons? From scratching sounds and missing cheese, we go to the existence of a mouse, which is not observed yet. If this is the case, then the cloud chamber tracks and electrical effects must take us to the existence of electrons, because both inferences go beyond what is directly observed. So the realist accuses Van Fraassen of drawing an arbitrary line. But I should say that the realist has a weak spot here. Everyday usage of IBE usually doesn't introduce a completely new kind of thing or entity into our worldview. When we hear scratching in the wall, we infer that there is a mouse. But we already know that mice exist. We are only inferring that there is another individual mouse here. So we are not adding a new category of entity into reality. What scientific realism wants is to accept entirely new type of entities like electrons and quarks. So the anti-realist might have a reason to treat these type of inferences more cautiously than ordinary mouse type inferences. Also, Van Fraassen defends a voluntarist epistemology, which I can't go into details in this video, but the basic idea is this. He treats rationality primarily as permission, not obligation. What does this mean? Let's remember the realist argument. The realist gave Van Fraassen two options. Either you reject IBE and become a total skeptic, or accept it and infer unobservable entities too. Van Fraassen denies the assumption behind this dilemma. The assumption is that an inference must either be truth-producing one or be rejected completely. By rejecting this, voluntarism lets him avoid two extremes, radical skepticism and scientific realism. He doesn't have to choose one of these. Another argument against realism is the argument from the best of a bad lot, which is also discussed by Van Fraassen. Suppose scientists are considering only three theories, T1, T2, and T3. They decide that T1 is the best explanation. T1 explains the evidence better than 2 and 3. Then, of course, IBE says infer T1. But what if all three theories are false? T1 would then merely be the best of a bad lot. There may be countless other possible theories that scientists have not considered. Maybe T4, T5, T6, and so on. How do we know that T1 isn't just the best of a bad lot? For example, suppose a doctor considers three possible diagnoses: a cold, an allergy, and influenza. Of these three, A cold explains the symptoms best. But the patient actually has a fourth illness that the doctor didn't even consider. A cold was the best explanation in the doctor's limited set, but it was still false. Similarly, a theory may be the best explanation in a poor group without being true. How can we be sure that we have included the best explanation in our set of rival theories? Because there is a risk of best candidates missing from the comparison entirely. So the realist has to be in a position to say that scientific methods are actually good enough to generate a privileged, so to say, set of serious candidates. And the realist actually does say this. Our set of competing theories is privileged in the sense that it is more likely to contain the approximately true theory than a random set of theories. And why does realists think this? Because scientists do not invent theories randomly, right? They don't start from scratch every time. And when you think about science's historical progress, it rules out many possibilities before comparison even begins. One challenge is that new theories must fit with theories that are already accepted, of course. Previous experiments have already eliminated many possibilities, so the theories scientists compare are not randomly selected from all imaginable theories. They have already passed through several filters. Therefore, the realist argues that available candidates are more likely to contain the truth than a completely random collection of theories. Now, before I finish the video, I'd like to mention one last objection to realism, which I think is very good. Recall the realist reasoning. Science is successful. The best explanation is that theories are true or approximately true. The anti-realist replies, why not explain scientific success simply by empirical adequacy? This was Van Fraasen's idea. In other words, theories predict successfully because they are empirically adequate. No appeal to truth is needed. Now here, the realist is not satisfied and says that we also need to explain why theories are empirically adequate. His answer was, they are empirically adequate because they are approximately true. When he says this, the anti-realist might counter this by saying, why doesn't truth require an explanation too? Why stop at truth? Why not continue? If empirical adequacy requires explanation by truth, why doesn't truth require explanation too? Maybe put God into the question or something else, some deeper theory. So why stop where the realist stops? If the realist answered this by saying, look, truth doesn't need a deeper theory, it's simply the way the world is. It is truth. There can't be anything deeper than truth. But in this case, the anti-realist can say that exactly the same thing about empirical adequacy. Perhaps empirical adequacy is simply the way the world is. Just stop at empirical adequacy. Right. This is it for this video, guys. See you on the next one.